Hello, Mr. Claudia here, and today we are going to finish off our sequence and series chapter talking about financial math. Now in the usual grade 11 class I get to do a whole chapter on financial math. It's one of the most practical chapters in high school math, but unfortunately we're going to cram it into one short lesson here. So hopefully there'll be lots of questions and interesting ideas that come out of it, and you'll be able to solve some of the word problems that IB expects of you using sequence and series. So let's just go over some general things and terms about banking. So if you go into a bank, a credit union, or any other financial institution, if you walk in, there are two reasons you want to walk in. One would be to invest, which means you have money and you want it to make more money. And the other reason would be to borrow, which means you need money and so you're going to ask for it from the bank. So investment, you give the bank money to invest. In exchange for taking your money, the bank is going to pay you some sort of interest, some amount kind of to hold your money. So an example of this would be a savings account. You guys might have something like this. Maybe a GIC, which is guaranteed investment certificate. That's when you get a fixed amount of interest, usually at a higher rate, but your money is locked in. Savings account, you can take the money out anytime. Your parents might have a retirement fund, also called an RSP. So this is where, again, I have a lot of money that I'm saving for when I retire. I don't have anything to do with it now, so I give it to the bank and they give me some interest, and I use that interest to help grow the amount I'll have when I retire. And then something I have now for my children, an education fund. So again, we have some money we're saving for our kids when they go to school after high school. That's in an RESP. Any idea what the current savings rate is? Like if you went to your bank, what would be the percentage you would get? What interest would you get? It's very low. Like right now it's like 0.5%. It's essentially nothing. Like you could, it's not much better than putting the money under your bed, under your mattress. It's not going to grow very much at 0.5%. Now, if you went to the bank and got a GIC, it might be something higher. I think sometimes you see things like almost 2%. So that's probably a better place if you're saving. You do a little bit better, but again, it's probably locked in for a few years, 3 or 4 years. So those are investments. Now we have the other side of the coin is borrowing. So this is where you need money, the bank gives you that money, but then you have to pay it back along with some extra, which is called interest. And you have to pay off that extra until the loan is paid off. So some examples of this would be a car loan. Like say you want to buy a car, you need some money because it's very expensive, you borrow money from the bank. The big one is a mortgage. This is a special loan that you use to get a house. This is very big numbers. The loan you might know or you might know soon is a student loan or an OSAP loan. So this is where the bank loans you money to use for school, and then you usually don't have to pay off the interest until after you graduate. And then another one that's common is a credit card. Right? A credit card is essentially you pay for something, you don't have the money right now, and then you can pay it off slowly with interest. Now, current mortgage rates are very low. It's usually, I think I've seen stuff for like 1.8%, which is a very, very, very low rate. It's gone down a lot. It's still higher usually to borrow money than to invest money. So usually the borrowing rate is slightly higher than the investing rate. And a credit card rate, well, I don't know if any of you guys have credit cards, but the percentage on a credit card is 20% interest. So it's very high, very, very high rate. That's why you should always try to pay off your credit cards. You don't want to use a credit card as a loan. It's not a great loan source. If you did want to borrow money to buy something, it's better to get an actual loan than to use your credit card. Okay, so that's just some basic info about banks. Now, some of the terms we're going to use in this section are, okay, well here they are. We have principal, or P. This is the amount that you invest or borrow. So this is the kind of amount that we're talking about. If you buy a $10,000 car, this is the amount you're borrowing, right? The principal. Interest rate is the money that you earn on the investment or pay on the borrowing of the money. and it's usually a percentage. So we talked about a few different interest rates. If you consider a bank as a place where you go shopping, you go to different banks to shop for the best rate, right? The interest rate is kind of how they're going to entice you. Sometimes you'll see deals like, oh, we'll offer you a GIC rate of 3%. And you're like, oh, I like that. That's a great deal. So then you choose that bank. So interest rates is almost like kind of like an advertising thing to get you to come to the bank. Compounding periods we'll talk about at the end of this lesson. That's the number of times that interest is compounded. It's not just, sometimes interest is given to you every year, sometimes it's given to you every month. That it can depend. Amount, or A, is the amount that the investment or loan is worth at the end or later. For example, after you've paid your interest. It's also called future value. So this would be the principal plus the interest. And term is a nice way of saying how much time. So, if you go to buy a loan, they're going to say, what's the term? They're just saying how many years. Okay, so let's start. We're going to look at two types of interest. We're going to start with simple interest. Simple interest is earned or paid. Again, we could be talking about investing money or borrowing money. Simple interest is only paid on the original sum of the money that was invested or borrowed. So, for example, you invest $5,000. Wow, that's great. You can save it for, when you go to university. The bank offers to pay you 3% interest per annum. Ooh, now per annum means every year or per year. That's a fancy bank word. So they offer to pay you 3% interest per year. How much will your investment be worth in 4 years' time? Okay, well, all right, let's look at the interest in 1 year. So you're earning 3%. Oh, sorry. We're talking about getting 3% of $5,000. Now, in math, of means multiply. So 3% times 5,000. So that's really 0.03 times 5,000. So 5,000 times 0.03, and that gives me 150. That's pretty neat, right? That's your interest. That's your free money. You get $150 free every year. Now, it's not really free. I mean, the bank is using your money that you've invested to do other things, to like make even more money. And they're just giving you a little kind of, a little bonus. But the bank is actually using the money to make even more money. But anyways, this is your interest. You can think of it as your free money. So now if I had to kind of map out what's happening here, this is kind of a map of time. So I have today, I have 1 year from now, 2 years, 3 years, 4 years, etc. Right? So kind of imagine time as this timeline. So today I have $5,000. Now in 1 year I have 5,000 plus that 150 interest. So that gives me 5,150. Now in 2 years, I have 5,150 plus another 150, right? I'm earning the same interest every year. It's simple interest. So when I calculate the interest, it's always based on the 5,000. 5,000 times 3% is 150. So now I have 5,300. Similarly, I have 5,300 plus 150. That gives me 5,450. And over here we have 5,450 plus 150 gives me 5,600. Now, you can kind of see how this fits in with sequence and series, right? This is increasing by 150. This amount that I have is increasing by 150 every year. So this is an arithmetic sequence where U1 is equal to 5,000, D is equal to 150. So we see then my investment would be worth 5,600, which is great. Now I will just, I don't want to dwell too much on this, but just to get this number, if you want to kind of shortcut it, this is essentially the amount is equal to the principal that I had plus, actually let me write this out this way. So I have $5,000 to get here, plus I added 150, 1, 2, 3, 4 times. So this was 150 times 4. So essentially, I'm getting 5,000 plus, sorry, how did I get the 150? Well, that was 5,000 times 0.03 and then times 4. So essentially, my formula is amount is equal to the principal plus the principal times the rate times time. So I'm not going to like exactly use the arithmetic sequence formula, but you get a sense that it is an arithmetic sequence, and I can kind of build the formula a similar way. It's the starting amount plus the starting amount times the rates, that gives me the annual increase, times the number of years. There is an n-1 difference, right? It's not n-1, just the way we count time today, and then in 1 year, I only advance 1 year instead of kind of that n-1 situation. So you can't directly use the formula, but you can see how it's related. That is simple interest. Now, before we go on to the second the second type of interest, compound interest, we do have a kind of a useful example to talk about. Stan's furnace breaks in the middle of February! Exclamation mark. Unfortunately, it's very cold. Unfortunately, he doesn't have enough money in his bank account to pay the $500 repair fee. He gets paid in 14 days, but this is an emergency and he can't wait. So he goes to visit the Cash Money Payday Loan store. These are these places you see kind of at the, you see them all over the city. And what they do is they lend you money if you haven't been paid yet. So they lend money at a cost of $15 for every $100 borrowed, and they charge large fees if you pay your loan late, which is more than 14 days. So the idea is they kind of will give you money if you're really close to being really close to payday, and it's a very short loan with a high rate. But it's the whole idea is that okay, you only need it to help for this emergency situation. Let's calculate the annual simple interest for this loan. Okay, we have to do a little bit of thinking. Again, this is more of a life example and not necessarily an IB example. But essentially the payday loan stores, and they publish these rates, these are not made up rates, they have $15 interest for every $100. I think that's what they said, $15 for $100. So what would that be? Okay. Okay, so for this guy's loan, he needs $500. So therefore, he needs $15 times 5 is equal to $75 interest for this loan. Hopefully that makes sense. Okay, so if we think about this, kind of formula I had, it was amount is equal to the principal plus the principal times the rate times time. So this is the amount I started with, this is the principal, and this is the interest. So my interest, we could say, is equal to PRT. Now, we know in the question, we just figured it out, interest is $75. The principal, the amount I loaned, was $500. The rate is the thing I'm trying to find out. And the time, well, what's the time? This loan is only for 14 days. So it's 14 days out of 365, right? It's a fraction of a year. It's not even a full year. It's not even half a year. It's a very small amount of a year. So let me sub that in. Again, I'm just trying to figure out the interest. So I have $75 for interest. That is 500 times the rate times 14 over 365. Okay, let's just solve this. So I have, well, I'll do 500 times 14 divided by 365. So I end up with 75 is equal to 19.178 R. Then if I divide 75 by that answer, I get my final result, which is R is equal to 3.9107. Now that is a decimal, so I want to change that into a percent. I multiply by 100, so I get 391%. Okay, and so that's why we have this example, because you see that with a payday loan store, you're actually paying 391% interest, which is crazy, right? Like the highest interest rate, I mean, if you get a car loan right now, it'd be like 5%. If you use your credit card, which is already a bad idea, that's 20%. But if you went to a payday loan store, you're paying 391%. So that's kind of a life lesson here. Never, ever go into a payday loan store. You will try to exhaust every other option you have before you do that. And at worst case, use a credit card. It's still not great, but it's much better than going to payday loan store. Here I have this is from the government is so concerned about payday loan stores. They actually make the stores put this up inside the store just to make sure that like people are aware of what they're doing. But if you're borrowing $15 for $15 interest for a $100 loan, you can see you're trying to show you how quickly it adds up compared to if you use a credit card. Because what happens is people get stuck in these kind of predatory lending situations where they can't pay off the full thing, so then more interest comes up, and they kind of get stuck in these payday loan stores, like owing them lots of money, where you know, usually a credit card will allow you to pay a little bit off every month instead of having to pay everything back at once. So these are really bad places. They're really horrible. Never go in one. And also, you know, hopefully you can help the other people around you so that they never have to go into one. They are not good ways of borrowing money. We all need to borrow money. Don't do it this way. Whew, okay, life lessons. Anyways, let's keep going. Compound interest. This is the other way of calculating interest, and this is much more common. Interest is added to the principal before new interest earned is calculated. So in other words, you're going to earn interest, and then the next year you're going to earn interest on that interest. And then you're going to earn interest on that interest on that interest. So you actually accumulate more interest this way. It compounds. Let's read this example. So you want to invest that $5,000. This time the bank offers to pay you 3% interest compounded annually. Compounded, right? So this is telling me it's something a little bit different. It's compounded every year. How much will your investment be worth in 4 years' time? Okay, so let's map this out. Again, we'll draw a little like kind of timeline to help me get this. So this is 4 years, and this is now, or today, sorry. Zoom out a little bit here so we can see. And then I have 1, 2, 3, right? So I have 1 year, 2 years, and 3 years. Okay, so today, pretty easily, I have $5,000. Put it in the bank. They have this great interest rate that got me in there. Now, how much money do I have the next year? Well, I have, okay, well, let me calculate the interest. The interest is going to be 5,000 times 3%. Remember, just like I did last time, multiply by that decimal. So that's going to give me a interest of 0.03. Oh yeah, it's 150. That's right. I should know that. So my total in my bank account at the end of 1 year is that $5,000 plus the 150. This gives me 5150. So actually it's pretty much the same for the first year. Okay, now after 2 years, well, 2 years they go to give me interest. And this time when they calculate my interest, they take the 5150. They take the amount that's in my bank account and they give me 3% of that. This is different than last time. Last time I only ever get 150, 3% of 5,000. But this time I get interest on my interest. Oh my God. So 5150 times 0.03, that gives me 154.50. That's not huge, but it's more, and that more, that extra 450 is again the interest on interest. So now I end up with 5150 plus 154.50, which gives me, oh my god, am I typing these things in wrong? 5150 plus 154, 5304. The interest on the next year, we have kind of a similar pattern now. I take the amount in my bank account and I multiply by 0.03. I get 159. So I get even more that next year. And now when I calculate the amount in my bank account, I have 5304.5 plus 159.135 plus 5304.5. And I end up with 5463.635. And we'll just finish this last one up. Interest is equal to 5463.635 times 3%. This gives me 163.909. A4 is equal to, I'm just going to show my answer. 5627.54. So you can see at the end of 4 years, I now have 5627 versus last in simple interest, I have 5600. So I have an extra $27. Now you might be thinking, oh, $27, big deal, but it is something. Like for your retirement, you'll be saving a lot more than $5,000. You'll have hundreds of thousands of dollars in the bank account eventually, hopefully, to have a nice retirement. So the percentage, the compounding counts. You're also going to be talking about a lot more than 4 years. You'll be talking about 10, 15, 20, 30 years. So every percentage counts, right? Well, it'll help grow your savings. Compound interest is that kind of idea, the rich get richer. The rich put their money in a bank account and you get interest and then interest on interest, and eventually they just live off the interest. Now, if we had to try to generate a formula for this, you can kind of see what's happening already here. Each time we're growing, well, actually, let's look at it this way. Our first year, we have our principal plus the principal times the rate, right? So I have the principal 100 or 5,000 plus 5,000 times 0.3. Now, we showed you this already. If I factor out the p, I end up with p times 1 plus r. A2 is A1, my previous amount, plus A1 times the rate. If I factor out A1, I end up with A1 times 1 plus R. Now I know what A1 is, it's P times 1 plus R. So if I sub that in, I end up with P times 1 plus R times 1 plus R. You could keep doing this. A3 then becomes P times 1 plus R times 1 plus R times 1 plus R. And A4 becomes P times 1 plus R, you guessed it, to the power of 4. So each time here, I'm multiplying by a common ratio of 1 plus R. I'll just write common ratio here so it's clear. Common ratio. And I'll write it's a geometric sequence. So the simple interest is the same amount every year. It always goes up by 150. The compound interest is being multiplied by 1 plus r. It's a geometric sequence. Now, even though in this case the rate's very low, right? 1 plus r is 1.03. It's still geometric. It's still growing by a common ratio, multiplying by a common ratio. From this, you can figure out the formula, right? It's my amount any year is equal to the principal times 1 plus r to the power of the number of years. But we're actually not going to get you to develop that formula. If you get a question on an IB exam involving compound interest, we have a formula that's given on your formula sheet. So we kind of developed it here, but I'm going to get you to learn this one because this is what is going to be on your formula sheet. And you can see that it takes a few minutes to figure it out. So we have future value, FV, or the amount that your investment or loan is worth, is equal to present value, or PV, which is what we had, P, times 1 plus R. Okay, R is the nominal annual interest rate in percent. So then to convert it to a decimal, you have to divide by 100. And then you have to the power of n, the number of years. So there's a slightly different, the formula, but essentially the same. Now, the one thing that we haven't talked about is the number of compounding periods per year. If you collect that interest every half a year, or every month, or every week, the rate changes and the number of years sort of changes. So these two numbers change. So we'll see how that works at the end of the lesson. But for now, this is just a nice way of writing, is the IB way of writing this formula that we just figured out, geometric sequence. So let's do an example. And in this first example, it's actually going to be a depreciation example. Depreciation is when something loses value over time. And depreciation is kind of the opposite of compounding interest. Depreciation means you go down by a certain percent every year and you get worse and worse every year. A great example of something that depreciates is a car. So in this example, James buys a new car. Good for James. And it's $27,000. The car depreciates at an annual rate of 20%. How much will the car be valued at in 10 years? Okay, so this question, well, let's just write out some of these things here. So it starts off with a present amount, or present value, of $27,000. It depreciates an annual rate of 20%. So the rate is 20%. How much will, now it's annual rate. So in this case then, the number of compounding periods per year is 1, right? It's only the money, the interest is only ever accumulated or taken away once per year. So this is going to be easier. And how much will the car be valued at in 10 years? So n is equal to 10. So this is the present value rather, and we want to find the future value. How much will it be worth in the future? So I'm going to use this formula. Future value is equal to present value times 1 plus r to the divided by 100k to the power of kn. So let's sub our things in. So we have 27,000 times, and this is 1 plus 20 divided by 100 to the power of 10. So you can see that we end up with 27,000, 1.2 to the power of 10. Actually, in this question, so you would say this is, if we were doing a growth question, this really mirrors this, right? Principal 1 plus rate to the power of t. Technically though, and I should have said this earlier, we're subtracting the value. This is a depreciation question. So we have 1 minus 20%. So every year my new value, or my new amount, is 0.8 of what I had before. So anyways, a little bit different because it's depreciation. I should make a note of that maybe. Subtract the rate instead of adding it. Okay, so now I take 27,000 times 0.8 to the power of 10. And what do we get? The car is worth $2,899.10. That's depreciation. The car has gone down quite a bit. It's gotten worse and worse every year. That's too bad for James. I mean, this is something you guys know with a car. You've heard the expression, as soon as you drive off the lot with a new car, it goes down by like 20-25%. You lose a quarter of the value just by driving it off the lot. This is why cars they're not really assets. They don't go up over time. A car, just a life lesson, a car is a liability. It only goes down in price. As again, you might have heard the expression, like, rich people don't buy liabilities, they buy assets. They buy things that go up. A house goes up in value. Investing in a company goes up in value. The stock market goes up in value. Even art, rich people buy art, they go up in price. Cars are treats. Cars are things that go down in price. So they don't actually make you money, they take away money. One of your biggest assets that you're going to be investing in soon is yourself. You're going to be paying for education, and that investment in education will bring your earnings up. But try to avoid buying a car, especially a new car, when you're a student, because this is more of a treat. It's something that just goes down every year. It depreciates. 10 years, hopefully he got a lot of driving out of it, but he's not going to be able to sell it for very much. Okay, let's turn in La Page. Okay, so this next example is another one that kind of teaches us a lesson about finance in the world, and that's because it involves inflation. Now, inflation is the rate at which prices go up. As you know, over time, things get more expensive. You hear that old story, oh, on my grandfather's day, they could, buy a chocolate bar for 5 cents. And obviously, prices have gone up, and that's called inflation. You might have heard of it in business class. In Canada and most of the Western world, the target inflation is 2%, and the Canadian Central Bank has some ways of trying to maintain it at 2%. This is our goal. We do want inflation to go up. We do want prices to go up a little bit every day or every year, but we don't want it to get out of control. And actually, there really is like a department of the government where people go into stores and record how much things cost. It's called the Consumer Price Index. They record the price of a bunch of things and they look at it over time, and that's how they keep track of inflation. So anyways, inflation is out there. It's a thing. You might think it's a dumb thing, but you could study some more of the economics of it and learn more about it if you really want. What we need to know is that 2% is kind of a nominal inflation. So if I buy a $5 Big Mac hamburger today, if it's $5 today, how much will it cost in 20 years, right? Because prices are going up. So in theory, the price of the hamburger will go up. So I can figure this out. Let me use this formula. Okay, so first of all, what's my principal or my present value? Well, that would be $5, right? That's what it costs right now. What else do we have? The rate. Well, the rate is 2%. And the number of years is 20 years. And in this case, we're going to just have one compounding per year, where inflation is something that they report every year. Okay, so now I have all these things. I want to find my future value, so I'm going to use that formula. Future value is equal to the present value, which is 5, times 1 plus 2 divided by 100, or 0.02 basically, to the power of 20. Let me type that into my calculator. So I end up with, 2 divided by 100, sorry, it's hard to see, that's 0.2 plus 1 to the power of 20 times 5. There you go. My future value in 20 years, using the compounding formula, the cost of a hamburger will go up to it's $7.43. $7.43. That's inflation at work. So this is inflation is something that's not going away. It's always happening. Prices will always go up. One important kind of thing that follows from this is that $1 today buys less tomorrow. So actually, your money gets more worthless every day, which is kind of a crazy way to think of it, right? You need only $5 to buy a burger today, but in 20 years, you're going to need more than $5. So that $5 can buy you less. So that's inflation. Now, where this kind of gets interesting, imagine you have $1,000 and you put in a bank account that pays 1.8% interest. How much money will be in your account in 20 years if you consider annual inflation of 2%? So we have a present value of 1,000. We have a rate. Well, the rate is 1.8% minus the inflation, right? The inflation is actually making your money less valuable. So you end up with, what is that, negative 0.2%. Your number of years is 20 years, and your compounding period is just once per year. So my future value was equal to 1,000 times 1 minus 0.2 divided by 100 to the power of 20. So we're going to get this minus thing, and you kind of probably have a sense of what's coming. So you get 0.998 to the power of 20 times 1,000. And I find that in 20 years, my money has actually gone down in price, gone down in value to 760.75. My money's depreciated. My money's gone down. Essentially, all of the gains I make from that interest are erased by inflation. Even though I have more money in my account, realistically, I can't buy much with it, right? I can buy less with it. So this is why you have to be really careful when you're investing your money in a bank account or some sort of investment. You might not want something that pays less than 2% because you're actually losing money. Inflation costs you. And you might, especially when you guys are younger and you have more time on your hands, you probably want to invest in a riskier investment that has a potential for a higher payout. For example, if you invest in some sort of fund that tracks the stock market, you're probably going to make 3 or 4% per year. So subtracting out inflation, you're still making money. You might have a bad year here or there, but over time it'll go up. So with that, I'll put that little kind of hint here. We must invest money long-term at rates above 2%. So example, an index fund, stocks, I don't know, whatever. I don't know too much about this stuff, but you get an idea that you have to kind of look around a bit more. You have to shop around. Okay, now let's talk about this compounding period. So far, we've always talked about doing things every year, but interest can be compounded different periods, more frequently than every year. So annual, okay, we already did this one. This means once per year, you're getting interest. Let's say you're getting that interest on December 31st. So that would be your rate, right? You get it, the interest rate is R, and the N is the number of years. Okay, now you're gonna have to, unfortunately, I did not make this change correctly. This is gonna be R divided by K, and this is gonna be N times, or K times N. These two correspond to the formula. So there's R divided by K, and there's K times N. So we're going to look at how these two numbers change as I change my compounding period. So semi-annually, or what you might see in an IB exam as half-yearly. This means you're getting your interest twice per year. So imagine you're getting some interest at the end of June and the other half of the interest at the end of December. So that would mean that you're going to receive, let's say you were getting 3% interest, you would get 1.5% of the interest in June, and then you get 1.5% of the interest in December. So your rate would be half, right? That 3% gets divided in half. So my interest rate goes down but I compound more than once. So if I'm compounding this for 10 years, well, I would actually have 20 compounding periods. So I'd have the number of years times 2. Okay, now quarterly. Let's say you get paid interest quarterly. Well, that's 4 times per year, right? The word quarter kind of tells us that. So then in this case, I take my rate, say I'm getting 4% per year. I'm going to divide that into 4, and I'm going to get 1% 4 times per year. So the number of compounding periods is the number of years times 4. I think you can see the pattern that's happening here. Monthly would mean that you get interest 12 times per year, every month. So whatever your rate is, you got to divide it in 12, and you're getting that, that amount of interest 12 times per year. Bi-weekly would mean every other week, so 26 times per year. Just so we have complete notes here, 52 weeks per year. Weekly, obviously there's 52 times per year. And then daily, probably not happening, but sometimes you see it, 365 times per year. That means you're getting interest every day. Of course, you're not getting, if you're getting 3% interest, you're not getting 3% every day. That would be crazy. That'd be a lot of money. You're getting a fraction, right? 365th of the interest every day. So let's watch how this works in practicality. Morgan needs to borrow $12,000 to help pay for grad school. A great investment, Morgan. This is much better than buying a new car, because when you invest in yourself in grad school, you earn more. Like it's a long-term investment that appreciates. So this is great. Morgan is doing the right thing. Borrowing money to pay for grad school. How much will she have to pay back if she borrows the money for 5 years and the bank offers her a loan with an interest rate of 4.2% compounded quarterly, 4.2% compounded monthly? So let's look at how these two questions are different. The first one, the present value, the amount that I'm borrowing, is $12,000. Okay, the rate is 4.2%. The number of years is 5. And then we have this issue with K, the number of compounding periods. Whoops, you can't see that. Okay. Well, the number of compounding periods, it's quarterly. So that means I'm going to be compiling 4 times per year. So if I want to find the future value, let me write out the whole formula this time. Okay, so now I'm going to sub in my number. So I have 12,000. 1 plus 4.2 divided by 100, and then divided again by 4 to the power of 4 times 5. So you get a sense of what we were talking about up here. The 4.2%, I'm dividing that into 4 pieces, and I'm getting that paid out. That small amount of interest is being paid out 4 times per year times 5 years. So let's do the math now. It would be 4.2 divided by 100 to get the decimal, divided by 4. So that's how much interest I'm getting every quarter. Add that to number 1, and I'm raising that to 20 because there are 20 compounding periods. And now I multiply that by 12,000. My final answer is 14,787.94 cents. So that sucks for Morgan. She has to pay back all of her money with about $2,000 worth, $2,700 worth of interest. But on the other hand, Morgan, is benefiting a lot from going to grad school, and sometimes you got to take advantage of that opportunity. What if she did the same loan, but it was compounded monthly? Okay, well, the present value is the same, 12,000. The interest rate's actually the same. The number of years is the same. So it's just the K value, which in this case, if you're compounding money monthly, is 12. So now the future value is PV times 1 plus R divided by 100K to the power of Kn. Let me sub in those numbers. So I'd have 12,000 times 1 plus 4.2 times 100 to times 12, or divided by 12 again, to the power of 12 times 5. Okay, so let's do this again on my calculator. 4.2 divided by 100 divided by 12 plus 1. So that's these. You can see how small the interest is per month. To the power of 60, because there's 12 times 5, times 12,000. And you get an answer of $14,798.71. So what do we notice? Well, both cases she pays a bunch of money, but actually she ends up paying more when the interest rate is, when the compounding period is more frequently. So let's just make a note. As interest is compounded more frequently, the interest earned or paid, depending on if you're borrowing or lending, increases. So that's something to be aware of. 4.2% changes a little bit. It's not a huge change, but it does change depending on if it's, every year, or every half a year, or every month. This is because technically there's an interest on interest being paid. Like, you have to think about this one. You're getting some interest put in your account, every quarter, and then you're earning interest next quarter on it. So in this case, it's even better. You're getting a little bit of money every month, and you're earning interest on that money every month. So this is why, like in a mortgage, for example, you pay. I pay monthly. So we have a monthly kind of accumulation of interest that the bank, I'm sure, loves, and I don't love. Whereas you might have a savings account where you only get interest at the end of the year. So that's something to be aware of, how compounding changes things. And questions like this, IB has kind of, directed that these sorts of questions are definitely part of the curriculum, and you could see something that involves finance. Your homework, I believe, is attached. Your homework is 8 questions that are on a separate sheet of paper. You have 8 questions there to do, and you have the answers there as well. So you'll be able to try your hand at finance. Good luck with that, and we'll see you next time.